With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello student, here our question is a hollow cube of side length L has two parallel sides conducting and the remaining four sides are non-conducting. Okay, this sided one is conducting and remaining four sides are not conducting. It is filled with a liquid of dielectric constant K. Okay, here if you're gonna fill this liquid with dielectric constant K, a small hole area A at the bottom of the cube is open at time t equal to 0. This is our small hole at the bottom of area A. Okay, the liquid start leaking through it. The liquid start leaking through it so that the two conducting sides are connected by a battery of EMF E. This is a two conducting sides are connected by the battery E. Okay, here length is given 9 meter and area is given 18 by root over 22, and this is root over 20 meter square for the small area A, and dielectric constant 10, and the electric that is potential difference, that is E equal to 81 volt, and G is 10 meter per second square. It must be 2 the second square acceleration due to gravity, right? So in this question we have to find the capacitance of the capacitor as a function of time, and here different options are given, that is epsilon by 9 t square minus 54 t plus 64, epsilon by 9 t square minus 54 t plus 810, epsilon by 9 t square plus 54 t into, that is plus 810, epsilon divided by 9 into t d square plus 54 t plus 64, right? In order to find that question we have to find that let us consider first, this is some, after some time t, this is the level of liquid, right? After some time t, this is the level of liquid fall through a distance L minus y. If we consider this from bottom to top, the distance is y, so this distance must be equal to, that is L minus y, because this is a cube of side length L. So if you consider this as y, so this is not visible clearly, right? So this is a distance of y, and this must be L minus y. Okay, so if we consider at time t, so this our capacitor will be divided into two capacitors, that is one is filled with a liquid of having dielectric constant K, and the one with empty one, that is there is no dielectric constant, right? So in order to find this we have to find we know that the formula for the capacitance C equal to A epsilon divided by, that is D. Okay, and what is the D? That is D is the spacing between these two plates. Okay, and we have to find the area, because area is varying. This is the plate, so area is varying due to this decreasing in the liquid. Y is decreasing, so area is varying. So we have to find the evaluate the area and then to find this capacitance of this capacitor. Okay, so here are two capacitor, that is one is with the dielectric constant K, as another is empty, so that they are connected in parallel, we can see here, right? So for parallel combination we can sum of these two capacitor, capacitance of these two capacitors. So now we have to find the y as a function of time t in order to find the capacitance as a function of time t, right? So in order to find y we have to use the fluid dynamics. Then two concepts in fluid dynamics which we have, that is velocity of flux, that is at this point if we consider this is a 1 and this is 2, so velocity at 1 is nothing, so we have to find the velocity flux first. Okay, so using velocity of flux concept, so we can find that our velocity at 2 equal to how much, that is using Bernoulli's equation, it will be root over of 2g into this y, height y. Okay, root over 2g y, this is the velocity of flux, okay, at velocity of 2. And in similarly we know that from here we can easily say that velocity from of this level, as the velocity the height is decreasing, so velocity of this level is nothing but minus of dy by dt, rate of change of displacement, right, negative direction. So we got this two velocity, and here is the area, instantaneous area will be how much, that is for the this one the area is always L square because there is no change in area, but here area is given, that is A. Okay, so now we are going to use the equation of continuity. Okay, what equation of continuity say, that is equation of continuity, and this equation say that is area 1 v1 equal to area 2 velocity 2, right? So we have the area at the top level, that is L square, and velocity for this top level is, that is, we have already found, it is negative of dy by dt, right? Now this is equal to area, that is area of this hole, and the velocity of efflux, velocity of liquid at this point, that is nothing but root over of 2gy, right? So in order to find the y as a function of time, so what we're going to do, that is integration, that is dy divided by y, that is the root over y, equal to negative of a divided by L square into root over of 2g, and here dt. Okay, so we are going to integrate this equation, okay, with the proper limit. And what will be the limit if we consider at time t equal to 0, height of this liquid was L. If we consider that time at some time t, what will be the height that is given y? Okay, we have taken this at after time t, the height from this bottom is L. At time t equal to 0, height from this bottom was L. That is height of cube, right? Now, after integrating all these things, we are going to get our result as 3 minus uh, t divided by 9. This t divided by 9 and the whole square, we are going to get our distance y as a function of time, right? So now in order to find the capacitance, what we're gonna do, that is for this first one, okay, here let me write here C equivalent. These are a parallel combination. So what we can take, that is area 1 epsilon divided, that is the distance spacing between them is L, okay, and this is the area 2, and epsilon into k divided by distance is L plus separation is L. Your A1 is, that is without dielectric, okay, this is the region of dielectric, and each it has an area, what you can consider, that is this is y into area, this is y into length L, okay, A2, and for L1 this is for this region only, this is L into L minus y, okay, area 1 equal to L into L minus y, and area 2 equal to A into L, y into L. This is L into L minus y into epsilon divided by L, plus what we have area 2, that is L into y epsilon into dielectric constant k divided by L. This is the expression for our equivalent capacitance, right? Now we are taking common all these things, that is uh, epsilon by L into what you have, that is L can be cancelled out, so we can omit this L, only epsilon is left. So this is L minus y into this is L minus y plus k into y, okay, this is the expression, and we have that expression, that is y equal to, that is 3 minus t by 9 square, right? So if we put here, that is epsilon into L, that is given 9, length is 9 meter, right, minus y is, that is 3 minus t by 9 whole square plus k into, that is k we can put directly value, that is given 10, k is directly constant this here 10, so this is 10 into y you have, that is 3 minus t divided by 9 whole square, okay. So what we are getting here, that is epsilon into 9 minus of, and this will be plus because 10 minus 1, that is plus 9, 9 of 3 minus t divided by 9, and this is whole square, right? Now if we take this term outside, that is 9 into epsilon into 1 plus 3 3 is 9 plus t square divided by 81, and this is negative of, this is what will be 2t by 3, okay. So from here what we are getting, that is 9 into epsilon, taking this 81 outside, this will be 81, and 9 plus 10, that is 81 10, okay, here multiplying, and the plus t square minus 3 into 27, that is 54 into 2, right? Now what we are getting, that is epsilon divided by 9 into t square minus 54t, let's say 1 I210. This is our equivalent capacitance, okay, C, sorry, this is C equivalent, and it is varying with time according to this equation. Okay, so if we check at our option, that 2 square minus 54 plus 810, that our second option is the right answer. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.